Hello and welcome to Structural Dynamics, the heat transfer simulations. In this tutorial, we are going to create implicit and explicit iterations for heat transfer in 1D, with the parameter is length L, the temperature on the left T left, the temperature on the right T right, the thermal diffusivity alpha, and some other parameters. To save up the time of commanding, I give here some default value for the parameters such as the file name is heat transfer 1d.give and the default tolerance is 0.01 Celsius degree. And we keep writing other default value for other parameters such as the final time of simulations, the time step dt, the time for exporting frame dt out, which is 1 hour, and the default space step, which is 5 centimeter if not input. Now we try to create a rate of the temperatures of each node on the road. So we need to know the number of intervals, and the number of nodes is number of intervals plus 1. In this matrix, the rows is the temperatures and the coordinate of nodes. The first column is the current temperature. The second column is the calculated temperature in the explicit and implicit simulation. The third column is the coordinate, so we can plot the graph of the temperature versus the space. And the fourth column is the guessed temperature in the implicit iteration. Now we get the temperature of all nodes. In the plot is the temperature at the right hand side, that's the environmental temperature. And the temperature on the left hand side is T left, which is the heated temperature. And we set the coordinate of each node, which is proportional to its index. And the last coordinate is the length. Now, to plot the graph to a file, we need to capture the plot. So we have to plot the graph of the temperature versus space, the distance first. And then we capture this frame. To be able to write a frame to a file, we need to convert the frame to image first, and then convert the image to index image. And I write to the give file with 0 delay time. Please reminder that it's a I might, not the I mean. And for the first frame, I set the loop count in. Now I start the simulations by setting the times is 0. And I keep looping until the time when our time values is equal or larger than TF, the final time step of simulation. In each loop, I get to the next time step by plus a dt to the current time. And I use the equation for the explicit iterations, which is the temperature in the future will equal to the temperature at the current step plus alpha times by dt over dx squared times by the temperature of the previous node minus 2 times the temperature of this node and plus the temperature of the next node. And after calculations, I copy the calculated temperature to the current temperature before moving to the next time step. To get a simulation, I need to export the frame when the time is a multiple of the DTL. So I do the same like I did before for the first time step. I plot the graph first. However, this time I add the timestamp to the title of the graph. And then I get the frame and I export the frame to the GIF file. Please remember that there is a lack of comma over here. And for the next time step, I try the write mode append to append the new frame to existing file. And I save it and try to get a run. Here I get the length is 2, the temperature on the left is 400, on the right is 220, and the diffusivity is standard of the structural steel. There are some errors, so we correct all of them by clicking on the respective line and run it again. So here is a simulation of the explicit iteration. Here is the exported file. Now we try to do the implicit iteration. So I comment out all of the explicit iteration. To get the implicit iteration, I must get the difference smaller than a tolerance, which is 0.01 by default. And I keep looping until the time difference is smaller than tolerance. So at the first time, I set the difference is 0 to compare later. And then I use the implicit equation to get the value of f. I try to use the Newton iteration to solve for this f. So firstly, I have to guess some value. I guess there is no change in temperature. So I copy the temperature in the second column to the fourth column. And I use the implicit equation. So to solve for the root of these functions, I get the value will be the value minus f on f dash. That's a Newton iteration. And then I try to see the tolerance. Which one is larger? And after calculations, I try to copy the calculated temperature to the guess temperature for the next implicit iterations. Please don't forget an equal sign over there. Yep, an equal sign over here. Now run it again. And I think the solution is almost the same. Thank you very much for your time and see you next time.